through the following trigonometric identities. I'm going to go ahead and work on the right side of the equation because it looks a little more complicated. And I'm going to write everything in terms of sine and cosine. So cotan is cosine over sine, and tan is sine over cosine. And then we still have our sine of theta, cosine of theta. Now for the numerator, I'm going to go ahead and use common denominator here. So you're going to get, when you have your common denominator is sine theta, cosine theta, you can cross these two. So you're going to get cosine squared minus sine squared all over sine of theta, cosine of theta. Now when you have a complex fraction like this, you can just multiply these two together. So I'm going to write this as cosine squared of theta minus sine squared of theta all over sine squared of theta, cosine squared of theta. I'm going to break this up because I have a minus sign here. So I'm going to write it as cosine squared of theta over sine squared of theta times cosine squared of theta minus sine squared of theta over sine squared of theta times cosine squared of theta. So let's see, these two cancel out and you have a 1. These two cancel out and you have a 1. Well, 1 over sine squared is cosecant squared, and 1 over cosine squared equals secant squared. And they match up, so you're good to go on that one. The next one, I'm definitely going to work on the right side of the equation. My common denominator is 1 plus secant times tan. Alright, now I'm going to go ahead and cross here, and you're going to get tan squared theta plus 1 plus secant theta squared. Now I'm going to go ahead and expand this, and remember that I'll put it under here, a plus b squared equals a squared plus 2ab plus b squared. So I'm going to go ahead and expand that and write this tan squared of theta plus 1 plus 2 secant of theta plus secant squared of theta. Alright, all over 1 plus secant theta times tan of theta. Okay, so let's see what we can do with this. We don't have any minuses here. So basically, I can write secant, do I want to do that? I can write tan squared as my identity. I'm going to write tan squared. I want to have all secants in the numerator. So tan squared equals secant squared minus 1. And I'm just substituting, so then I'm going to add my 1 plus 2 secant plus secant squared of theta. Now all over my common denominator. 1 plus secant times tan. Now what happens is these two cancel, and we have 2 of these. So that's going to be 2 secant squared and secant. I'm going to try to squeeze it in here so we can keep the train of thought going on. So I have 2 secant squared plus 2 secant. Now, if I factor out a secant, I'm going to get secant times secant theta plus 1 all over 1 plus secant times tan. Now what happens is this cancels. Oh, and don't forget your 2. Let's just say we factored out the 2. I forgot to factor out this 2. Okay, so that cancels, and you're left with 2 secant over tan. Okay, so let's go to the next slide. 2 secant over tan. So I'm going to rewrite this real quick in terms of sine and cosine. So this is 2 over cosine, and tan is sine over cosine. So what happens here is the cosines cancel. You get 2 over sine, which is going to be, 2 over sine. Getting ahead of myself. 2 over sine. Remember, 1 over sine is cosecant, so this is going to be 2 cosecant of theta. And that's it. Thank you. Have a nice day. Bye-bye.